Hi guys, welcome back to the channel. In this video we are going to see the half adder implementation with the help of two multiplexers, that is 2x1 multiplexer and 4x1 multiplexer. So how to implement the half adder with the help of these two multiplexers we are going to see in this video. So let's get started. So this is the half adder circuit diagram and the block diagram, and these are the sum and the output carry expressions. If you want to know more about half adder and this block diagram and full adder, I am giving the video in the description box, check it out. So in this video we are just going to have just implementation. So first, with the help of 4x1 multiplexer we are going to implement the half adder. So if you observe, we have the truth table, that is AB. We have total two variables, means we can implement, means two variables means two select lines. So two select lines means we have two select lines, so that is we have two variables. So we can pass the two variables into the two select lines, that is AB. So we can directly send AB to the select lines. So we have four input lines, that is from D0 to D3. So I hope you know the truth table. We have total four combinations from 0 to 3. So sum is, I hope you know how to get the sum and carry. So the sum in terms would be 1 and 2, because there are positions 1. Because in that positions we have ones in the column, sum column. So carry, the min term would be D3. So just first let's start with the implementation of half adder in the 4x1 multiplexer. First let's see the sum. So if you consider the sum, this is the min terms, that is 1 and 2. So directly, or because we have select lines as A and B, so you are just going to pass all the sum outputs in as inputs in the 4x1 multiplexer. Suppose if you want to any output in the form of output, that is in the 4x1 multiplexer, just you are going to pass inputs, that is select lines, that is AB. Suppose if you pass AB as 1 1, you are going to get as D3 output. What is D3 we are passing here? That is 0. So likewise, if you want anything, we can obtain output as in the sum. So if you want the carry for the 4x1 multiplexer, so in the same way for the carry column also, you are also going to pass all the outputs in the truth table as inputs in the 4x1 multiplexer. So if you want any of the carry to be passed as output in the 4x1 multiplexer, you are just going to pass A and B according to that. So if you pass A and B as 1 1, so you are going to select D3. So what is D3 we are passing? Just 1. So simply I hope you are understanding. Just we need to pass all the outputs as inputs in the 4x1 multiplexer. So the next step is the half adder is implemented with the help of 2x1 multiplexer. So the truth table would be same. We have AB and we have some output expressions. So with the help of 2x1, how we have to implement, let's see. So because of we have two variables, that is A and B, so we are going to pass one variable because we have only one select line. So in the one select line we are going to pass one variable, that is A. So the remaining one variable, that is B, we are going to pass as inputs. So as we are going to compare the B and sum, so we are going to express the sum in terms of B, so that we are going to pass the inputs. So if you observe that sum and B, so we have some relation between sum and B, that is both are same. So S is equals to B. So I have represented in the 2x1 multiplexer also that I0 is B, directly passing there. In the same way, next we are going to compare the next two, that is we have some relation between S and B over the next two also, that is for I1. For I1, because if A is equals to 1, we are going to select I1 in the 2x1 multiplexer. So then you can compare that. So when B is equals to 0, sum is 1. When sum is 1, B is equals to 0. So like vice versa is changing. So we can say that S is equals to B bar. So I1 also we are going to pass the B bar. So I hope you are understanding this. So when A is equals to 1, we are going to select I1, that is B bar. So this is the implementation of the half adder with the help of 2x1 multiplexer. So in the same format, if you want carry also, you are going to have the carry column and you are going to compare the carry and B, because we have already passed A as select line. So if you compare carry and B, so first you can observe there is no relation between B and carry. So B is so forgot about B. If you consider C is changing from 0 to 0. So C is 0. So pass I0 as 0. So if you compare next one, both are same. B and carry would be same. So C is equals to B. So pass B as the I1 in the 2x1 multiplexer. So this is the implementation of half adder carry with the help of 2x1 multiplexer. Finally, this is the circuit diagram or block diagram of 2x1 multiplexer implementations of sum and carry. So you can see that already we have seen this, but this is somewhat elaborated thing for sum, because first I0 is B, I1 is B bar. So instead of representing B and B bars, I am taking a variable line B and I am taking from B bar. So simply attach both of them, you can get a clear picture of sum. So carry is same, that is as it is. So I hope you understood all these things. So we have discussed the implementation of half adder with the help of the 4 cross 1 multiplexer and 2 cross 1 multiplexer, and we also discussed the sum and carry for all things. So thanks for watching up to now.